Welcome to the DIY Honda Garage channel. The DTC P0335-31 indicates an issue with the Crankshaft Position CKP sensor in the Honda CR-V 2023 and newer models. This specific error occurs when the Powertrain Control Module, PCM, detects a lack of signal input from the CKP sensor while the engine is running. The CKP sensor plays a crucial role in monitoring the position of the crankshaft, which is essential for the correct timing of the engine's ignition and fuel injection. It is typically located near the crankshaft and is integral to the engine management system. When the PCM fails to receive any signal from the CKP sensor, it considers this a critical fault, logging the DTC and activating the check engine light on the dashboard. This prompts a thorough diagnostic to determine the root cause, the sensor itself, wiring issues, or a malfunctioning PCM. The DTC P0335 indicates that the crankshaft position CKP sensor is not providing any signal to the PCM. This sensor is crucial to the engine's operation as it relays real-time data regarding the crankshaft's position to the PCM, allowing it to manage ignition timing and fuel delivery accurately. If this sensor fails or does not output a signal, it can disrupt the engine's firing timing, resulting in poor performance or the engine not starting at all. The CKP sensor is usually mounted on the engine block near the crankshaft, making it necessary to access this area for inspection. Its absence of signal directly implies that the engine management system cannot function correctly, which may lead to not just performance issues, but also potentially damaging the engine in the long term. Therefore, immediate troubleshooting is recommended to identify the cause of the problem. The DTC P0335 may arise from several potential causes. Firstly, the CKP sensor itself could be faulty or damaged, leading to the failure in signal transmission to the PCM. Secondly, there may be issues within the wiring harness connected to the CKP sensor. These could include frayed wires, poor connections, or corrosion at the terminals, all of which can impede the sensor's performance. Additionally, the PCM, which interprets signals from various sensors, may exhibit malfunctions or programming errors itself, leading to erroneous fault codes. Each of these factors must be considered when diagnosing DTC P035 to pinpoint the exact cause of the no-signal condition. By addressing these issues, one can restore proper operation and avoid further complications. Several symptoms may point towards the presence of DTC P0335 in the Honda CR-V. One of the most immediate signs is the check engine light illuminating on the dashboard, alerting the driver of a fault in the engine management system. More critically, the vehicle may experience difficulty starting. Without a signal from the CKP sensor, the PCM is unable to trigger the ignition system correctly. Additionally, if the engine does start, it may run roughly or inconsistently due to improper timing between fuel injection and ignition. These symptoms not only highlight the urgency to troubleshoot the CKP sensor, but also serve as indicators of larger potential issues if left unaddressed. The first step in troubleshooting the DTC P0335 involves starting the engine to determine whether there is any signal from the CKP sensor. This step is crucial as the PCM requires this signal to manage engine operation effectively. With the engine running, the technician should scan for any signals being sent from the CKP sensor. Observing live data or using a diagnostic tool can provide insights on the sensor's functioning. If the PCM does not receive a signal during this test, it confirms that further inspection of the sensor and its related components is necessary. This initial test serves as a foundational step in determining the overall health of the CKP system. In the second step of troubleshooting, DTC P0335, the focus shifts to inspecting the CKP sensor and its connections. Given that a faulty connection could lead to the absence of signal, it is vital to check for corrosion, looseness, or physical damage at the CKP sensor connector. Additionally, the wiring associated with the CKP sensor should be thoroughly examined for any signs of fraying or breaks that could disrupt the circuit. Ensuring that the connections are clean and secure can often resolve simple issues that contribute to the no-signal condition. This phase is crucial as it addresses the possibility of external factors causing the sensor to malfunction, emphasizing the importance of connectivity in the overall sensor system. The third troubleshooting step is to inspect the VCC1 circuit for any issues that could cause a no-signal condition. The VCC1 circuit delivers the necessary voltage supply to the CKP sensor, and any interruption, such as a break or short within the wiring, could prevent the sensor from operating. Using a multimeter, the circuits should be tested for continuity and resistance. A reading of less than 1 ohm indicates normal conditions, while higher readings suggest an open circuit that needs attention. Paying particular attention to any connection points is essential, as this can often be the location of a fault. By establishing the integrity of the VCC1 circuit, one can confirm that the CKP sensor has the required voltage to function properly. The next step involves inspecting the CRKP circuit, which carries the signal from the CKP sensor to the PCM. Like the VCC1 circuit, any breaks or shorts could prevent the proper signal transmission, leading to the DTC P0335. A multimeter should be used again to measure resistance. A reading of less than 1 ohm suggests a healthy circuit. Conversely, resistance readings that are significantly higher can indicate that there is an open circuit or that the wiring is damaged. Careful examination of this circuitry will provide insights into whether the CKP sensor can communicate effectively with the PCM, or whether a fault in the wiring is to blame for the lack of signal. Inspecting the CRKP circuit is essential for maintaining the overall functionality of the CKP sensor system. In this fifth step, the SG1 circuit is evaluated for any potential faults that could contribute to DTC P0335. The SG1 circuit typically serves as a ground reference for the CKP sensor, making its integrity vital for sensor operation. Much like with previous checks, the continuity and resistance of the SG1 circuit should be measured using a multimeter, aiming for a reading of less than 1 ohm. Higher resistance may indicate problems such as disconnections or shorts to ground, which would impact the signal reaching the PCM. Establishing that the SG1 circuit provides an effective ground is critical in ensuring that all components, including the CKP sensor, can operate correctly, aligning with the PCM's expectations. The final step in troubleshooting the DTC P0335 involves inspecting the PCM to identify any potential malfunctions. If the CKP sensor and its wiring have been verified as functional, yet the error persists, the PCM might be at fault. Using diagnostic tools, the PCM can be evaluated for stored codes and operational integrity. If it fails to show expected signals or continues to indicate a no-signal condition, this may confirm a PCM issue. Testing different components of the PCM, such as its inputs and outputs, will provide clear insights into whether this unit is functioning properly or requires replacement. This step underscores the critical nature of the PCM, as it serves as the central hub for engine management systems. After completing the troubleshooting steps for DTC P0335, it's crucial to carry out a final verification process to ensure repairs are effective. Begin by clearing the DTCs from the PCM using a diagnostic tool and then proceed to test drive the vehicle. This step allows for real-world assessment of whether the issues have been resolved. Monitoring the engine behavior under normal driving conditions helps confirm that the CKP sensor is now providing the necessary signal and that the PCM responds appropriately. Observing the absence of the check engine light during this test confirms that the repairs have been successful, allowing for the safe operation of the vehicle. Should any fault codes reappear, further examination may be needed. To prevent future occurrences of DTC P0335 and ensure the longevity of the CKP system, regular maintenance checks of the wiring and connector integrity is highly recommended. Periodic inspection of the CKP sensor, along with its related circuits, allows for early detection of wear and potential failures. Keeping these components clean and free of corrosion is crucial for maintaining an effective electrical connection, which is essential for sensor operation. Additionally, reviewing the engine's operation parameters and ensuring that no contaminants or physical damage affect the sensor will optimize its performance. Performing these preventive actions will contribute significantly to the vehicle's reliability and maximize the lifespan of the CKP system. In summary, understanding and effectively troubleshooting DTC P0335, indicating a no signal from the CKP sensor, is vital for maintaining engine performance in a Honda CR-V 2023 and newer models. The CKP sensor's role in engine timing and fuel injection cannot be overstated, as a malfunction can lead to significant operational issues. Thorough inspections of the CKP sensor, related wiring, and the PCM guide the diagnostic process and lead to successful repairs. Regular maintenance can further aid in preventing reoccurrence of issues related to DTC P0335. By adhering to proper troubleshooting protocols, technicians can ensure the engine operates smoothly and efficiently for years to come. Please like and subscribe to the channel. See you next time.